Okay, hello guys, in this video, just want to go ahead and find the values of x for which this equation will be satisfied. That is to say, for which we're going to have that 1 over x is equal to negative of x. Well, this is very, very impossible because from the diagram of these two functions right here, there is no point where they intersect. That is to say, there is no solution. This is what I mean. When we want to plot the graph of 1 over x, we will have on the xy plane, it's going to pass like this without touching the x and the y axis, and so on. That is for the 1 over x. That is f of x is equals to 1 over x and 1 over x also here. Now, the other right hand side, negative of x, it is a decreasing function passing through the center like that, right? It's just a linear man. But unfortunately, these two curves, they don't meet at any point. That is to say, there is no way we can have a solution for this kind of equation. Well, the truth of the fact of the matter is that there's no place there's no number, that is, there's no x value in which these two curves will meet. So that means that there is no real solution. Okay? There is no real solution. So this implies that x has no real value. Now here is a question. Could x be complex? So could x be complex? So since x has no real value for which the equation will hold, can x have any complex value such that that equation is satisfied? Well, I would like to just try it and see, okay? Let's suppose x to be a complex number, alright? So let x be written as a plus ib. So this is a complex number where a and b are real numbers. Okay, and again, you know that from this equation, x is in the denominator, so that simply means that x is not going to be 0. Okay, so x will be 0 if a and b are 0. So that means that a and b not 0. Okay, a can be 0 on its own, b can be 0 on its own, but not the two of them, a, b to be 0, because that would just make our x to be 0. And if x is 0, we're just going to have 1 over 0, and that doesn't make any sense, alright? Okay, so we just go ahead and put a plus ib for x in the equation and try to see if we can find a complex number to assign to x in order to have a complex solution, since we can't have a real solution. Okay, so since we are saying that x should be a plus ib, it simply means that 1 over a plus ib is going to be equal to negative of a plus ib, alright? Okay, just by doing that, well, we can just go ahead and multiply a plus ib on both sides. We're going to have that 1 is equal to negative of a plus ib, and that alone, just square of that. So from here, we can just go ahead and expand this right hand side. We're going to have negative of a square plus 2iab and minus b square. You know, by the binomial expansion, here is going to be ib square, where I square is negative 1, and we just put d down, negative b square. Okay, so this is just the one on the left hand side. Now we are going to go ahead and take this out. We're going to have 1 equals to b square minus a square minus 2iab. So on the left hand side, we see that we are just having 1 there, meaning that the imaginary part there is 0. So if you're going to equate the parts together, the real part to the real part, the imaginary part to the imaginary part, we will just observe that 1 is equal to b square minus a square as the real part, so we can just call that the first equation. And again, 0 is the imaginary part on the left hand side. We're going to go ahead and equate that with negative 2ab. Okay, so that makes a lot of sense, isn't it? So we can just go ahead and call this our equation 2. Now, from equation 2, we see that product of two unknown numbers, okay? This negative 2 is a known number, so it doesn't really matter. The product of A and B will be giving us 0. That means A could be 0 or B is 0. So I can put it down that from equation 2, A is 0 or B is 0. Okay? Now, suppose I'm going to test for the two cases where A could be 0. I'm also going to test for when B is going to be 0. Okay, so let's just go ahead and look at this. Okay, let me just put it down as case 1. Case 1, if A is 0 and B is non-zero. Remember what I said? A and B should not be 0. So if A is 0, that means B should be non-zero. It means that we're going to have, from equation 2, this is just the case 1. Okay, it means we're going to have that 0 is, from equation 1, it's 1, okay? It means that we're going to have that 1 is equal to, this is just the difference of two squares, so we can identify it to be B minus A times B plus A. That means that we're going to have that 1 equals to, so where A is going to be 0, just plug in 0 right there, we're going to have B times, again, 0 is there, we're going to have B again. So that means that we're going to have that 1 equals to B squared, implying that B can be positive or negative 1. Okay, so those are the two values of B when A is equal to 0. So we can just try and test these values. Just plug it in to X and we're going to get something nice for X, alright? So we record that X is equal to A plus IB. That means that X is going to be equal to 0 for A, okay, if A is 0 and B is non-zero. So 0 for A plus B is positive or negative 1. So that means you can have positive or negative 1. That is I times 1. That is just I. So X can either be a positive I or it can be a negative I. That is when we take A to be 0 and B to be non-zero. What if in the other way around, I say let's make B to be the 0 and A to be the non-zero? Let's just see what we're going to get, alright? Okay, so case number 2, if B is 0 and A is non-zero, right? That means that we're just going to enter with, from equation 1, we're going to enter with 1 equals to B minus A times B plus A. So where B is 0, 1 will be equal to negative A times A again. Okay? Well, when B is 0, we just add A to 0, gives us back the A. That's our additive identity. Okay. So by just looking at this, we're going to have that negative 1 is going to give us A squared. That means that A on its own is going to give us positive or negative I. So if you want to check for X again, X is going to be equal to A, which is positive or negative I, plus B plus IB, where B is 0. So that's just going to be plus 0. So that still leaves us with X equals to A plus IB. So it is the same result we had initially for X. That means that we can actually find a complex result for a complex value for X. So if X is I, positive I or negative I, shows that this equation will be satisfied. So that means that X is not a real number from the graph we just plotted, that X is going to be an imaginary number. And of course, it's going to be the positive unit imaginary complex number or the negative I. Okay. Well, I know that from here we can just say let's add X to both sides, and by adding X to both sides we just find just try to make x subject of formula by taking the square of both sides, and it will give us the same result, alright? But I just wanted to look at this analytically to see if, looking at it this way as an abstract student, okay? That I am, alright? So thanks for watching, and as well, please subscribe to this channel, alright?